If you've ever worked with data, you know that SQL joins are absolutely essential for connecting information from different tables. But what happens when all the clues you need are actually hidden inside one single table? Well, today, we're going to crack that code. So here's the central puzzle we're tackling. How in the world can a table be joined with itself? I know, it sounds a little counterintuitive, but trust me, mastering this technique is the key to solving some surprisingly common and tricky data problems. Think about mapping out a whole company's reporting structure. This is how you do it. Okay, first things first, let's start with the classic case. As a data detective, you're often going to find clues split across two different tables. And your mission? It's to piece that full story together. So on one side, you've got a list of employees with a department ID, and on the other, a list of department IDs with their actual names. We know who works where by their ID number, but what we really want is the full picture, employee names right next to their department names. So what's the mystery? How do we link them? To solve this, you need a basic toolkit, and in SQL, that toolkit is your set of join commands. These are really the bread and butter of database queries, so let's do a quick review of the essentials. Your main tool, your go-to, is the inner join. Think of it as finding the perfect overlap between two datasets. It will only show us employees who have a matching department in the departments table. If there's no match, well, they just don't make the list. It's simple, it's direct. But what if you want to see all of your employees, even the ones who don't have a department assigned to them yet? For that, you're going to use a left join. This query, it prioritizes the left table, in our case, the employees, and it pulls in the department info wherever it finds a match. And if there's no match, it just leaves that spot blank. No big deal. And you can just flip that logic on its head. To see all the departments, even the empty ones that don't have any staff, you'd use a right join. This time, the right table, the departments, is the priority, and we only pull in employee data where there's a match. So the crucial point here is that each join in your toolkit is designed to answer a slightly different question about how your data is related. Inner gives you just that perfect overlap. Left and right give you everything from one side plus that overlap. And full outer, well, that gives you pretty much everything from both sides. But now for a new case, a real head-scratcher where all the clues you need are hidden inside just a single table. This is where things get really clever. Okay, take a look at this table. We've got employees, their employee ID, and their manager's ID. You see Frank's manager has an ID of 8. And we can see right there on the table that employee ID 8 belongs to Mike Dyson. But how do we get a query to tell us that? How do we use SQL to find out that Frank's boss is Mike Dyson? In this is where our secret technique comes in. It's not some brand new type of join command. Nope. It's just a really clever way to use the joins we already know to make a table talk to itself. The key, the whole trick, is to treat one table as if it were two separate, identical tables. You're basically creating a logical copy of it in your query, so you can match rows from the, let's say, employee copy with rows from the manager copy. And the magic behind this trick is using what we call aliases. We basically tell SQL to treat the employees table as two different things in the same query. We can call one copy E for employee and the other copy M for manager. Then we can just write a condition that says, hey, match the manager ID from the E table to the employee ID in the M table. So the process is actually pretty simple. You start with your one employees table. Then you create a logical copy of it, which we'll think of as the managers table. And finally, you connect them by matching the employee's manager ID column to the manager's employee ID column. And boom, it's done. Once you get the hang of this technique, seriously, you can solve all sorts of internal data mysteries. It's perfect for hierarchical data, like org charts. But believe me, its uses don't stop there. For example, let's solve this case. How do you find pairs of employees who earn the exact same salary? See, this isn't about hierarchy at all. It's about finding duplicates or just interesting pairs within the same dataset. So our source data is, again, a single table. We've got worker IDs, first names, and their salaries. And you can see with your own eyes that Amita and Vivek have the same salary, and so do Geetika and Abhiji. A self-join can pull these pairs out for us automatically. Okay, so here's the two-part logic. First, you join the table to itself using aliases. Let's say W1 and W2, and you match rows where W1.salary equals W2.salary. But wait, that would just match every employee with themselves. So we add a crucial second condition. W1.workerID must not equal W2.workerID, and that gives us only the true pairs. Before you go, there's one final crucial clue every data detective has to know. Choosing the right tool for the job really matters, because choosing the wrong one can lead you straight into a trap. Let me introduce you to the cross join. Unlike the other joins, this one doesn't have an on condition. Its whole job is to match every single row from the first table with every single row from the second. Now, it has some pretty niche uses, but it's a command you really need to handle with extreme care. So just imagine for a second you accidentally use a cross join, or maybe you just forget your join condition, on two tables that are only moderately sized. Let's say each has just 1,000 rows. Doesn't sound like that much, right? The result is an enormous 1 million row table that can slow your system to a crawl. So the takeaway here is to always join with purpose and with a clear condition. You've got to understand your tools, or you might find yourself in the middle of a performance disaster. And there you have it. With these techniques, especially that clever self-join, you're now equipped to find relationships in your data you never even knew existed, linking employees to managers, finding users with similar behaviors, or spotting duplicate records. The clues are all there, just waiting for you to connect them.